So again, I am plotting the function. This time the function is x cubed, and I'm no longer finding the tangent line. Here I am just plotting the function against its derivative, right? So I put both of those in the same plot. And so here what I have is x cubed. The blue line is x cubed. The red line is the derivative of x cubed, which is 3x squared. Now, the value of this is that it shows you another application, so to speak, of the derivative. The derivative tells you where the function is increasing or decreasing. Now, x cubed is increasing pretty much everywhere, right? It's always increasing, except kind of at 0, but everywhere else it's increasing. And the derivative is positive everywhere. So that's an important lesson. Notice, when we're talking about the increase or decrease of a function, we're talking about its tendency, or you can imagine all of these tangent lines hitting the curve. And that's what we're talking about when we're talking about increase, is the fact that the tangent line points upwards, say. And we are relating that to the fact that the derivative is positive. So notice, even though the function is negative down here, the fact that it's going up, it's tending higher and higher, means that the derivative is positive above the x-axis. This is a point that a lot of students get confused about too, is that they think, because the derivative is positive, then therefore the function must be positive, or certain sorts of things like that, which is not true. Or because the function is negative, therefore the derivative must be negative. No, the location of the function is not important when it comes to figuring out its increase or decrease, right? You could be down here or you could be up here on the function and still see increase or decrease. But what is important about location is the location of the derivative, right? It's the fact that the derivative is located in the positive region tells you that the function is increasing. So the location of the derivative matters for increase or decrease, but the location of the function itself does not matter for increase or decrease. Let's see this again. So let's plot a few of the other functions. So here I have the blue curve being sine. I have the red curve is the derivative, which it turns out is equal to cosine. And don't worry, in case this is a concern, you don't need to know all of these derivatives just yet. I'll be talking about them in greater detail in future videos. But just sort of notice the shape of the curves is all I really want to focus on right now. So notice that where sine is increasing, which is from what looks like about pi over 2 to negative pi over 2 to pi over 2, I promise you that's correct, that's the same region where cosine, its derivative, is positive, right, above the x-axis. So sine is increasing where cosine is positive, and sine is decreasing, starts decreasing right at the point where cosine dips down below the x-axis. So that's another example of seeing how the derivative tells you where the function is increasing or decreasing. Let's see it one more time with one more example. E to the x. So the program represents e to the x as exp, but in any case, we don't even see the blue curve, right? Because both of them are e to the x, right? We saw even earlier on when we just ran this code that the derivative of e to the x is e to the x. So so that's why you can't even see the two functions in this. But what's interesting is to think about the interpretation as telling us something about increase or decrease. So right here, when x is equal to 0, y is equal to 1, the function is increasing. And in fact, because the derivative is positive everywhere, therefore the function is increasing everywhere, which we know from the shape of the graph, right? That actually makes good sense. So the derivative is positive everywhere, therefore the function is increasing everywhere. You know, there's well, I'll leave it at that. But so you should definitely take away from this video the ability to look at the derivative of a function, look at the graph of the derivative, and figure out where it's increasing and decreasing. Because if you're looking at the derivative, you just got to figure out where is it positive. That'll tell you where the function is increasing or decreasing.